Hello students, this is Mrs. Youd, and today I'm going to go over Chapter 1, Section 1 for Algebra 1. And these notes are taken from the student journal that you picked up at school. So if you don't have that, you need to pause the video right now and go and pick up that journal. We are working on pages 4, 5, and 6 today. So a conjecture is an unproven statement about a general math concept, whereas a rule and a theorem kind of mean the same thing, and these are statements that are proven. An equation is a statement that shows that two expressions are equal. For example, if we had x plus 50 is equal to negative 7, the whole piece here would be your equation, and each part of the equal sign are your two expressions. A linear equation in one variable is an equation that can be written in the form ax plus b is equal to 0, where a and b are constants and a cannot equal to 0. A solution is a value for the variable that makes the equation true. Inverse operations are two operations that undo each other. And equivalent equations are equations that have the same solution. For example, if I have this simple problem x plus 50 equals negative 7, this is an equation, and if I wanted to solve for the variable x, then I would draw my line here and I would have to undo this plus 50. I would need to do the inverse operation for that plus 50. And the inverse operation is to subtract 50. So if I do it on one side of the equal sign, I have to do it on the other side of the equal sign. And what happens in this case is positive 50 and negative 50 cancel out to 0. And what we end up getting is x on the left, and on the right we get negative 57. And so this is my solution. So when we talk about a solution, that's what we're talking about. What is the answer for the variable that makes the equation true? In the case, this is my equation, this is my answer, or my solution. And these are actually equivalent equations. This is an equation here, and this is also an equation here. And they are equivalent equations because they're two equations that have the same solution. There's some core concepts that we need to know about. The first is the addition property of equality, and that is if you have any number a equals b, you can add something to both sides of the equation and it still makes it true. It's still an equivalent equation. For example, if you have this equation x equals 3, then you know that this is also true. X plus 5 equals 3 plus 5. All I did was add 5 to both sides of the equation. On the next page here is the subtraction property of equality, which says if you have any number, anything a equals b, then you can subtract the same thing on both sides and it will still be true. For example, if I have x equals 3, I can subtract 5 on both sides and it's still true. The multiplication property of equality is the same sort of thing. You have two variables that equal each other. If you multiply the same thing on both sides of the variable, then it will be true. The only thing that needs to happen is the c that you multiply by cannot be 0, because then you'll have a divide by 0 error. And here's the example. If x equals 3, then x multiplied by 5 would also equal 3 multiplied by 5. And lastly, the division property of equality. If you have two things that equal each other, then dividing by the same number again, or dividing by the same amount will give you the same equivalent equation. And once again, that thing that you divide by, whatever you divide by, cannot equal 0. And here's my example. You know that I did my division as a fraction because that's perfectly acceptable. Fractions and division mean the same thing. Okay, on the next page we have some practice problems. In exercises 1 through 9, we want to solve the equation, justify each step, and check the solution. So in number 1, we want to solve for w. I always suggest that students circle the variable and draw a line at the equal sign. And so what we're going to do is do the opposite of plus 4, which would be minus 4 on both sides. And so we end up getting w is equal to 12. And so that is the solving of the equation. Our justifying of each step is using the subtraction property of equality. And for checking our solution, we're going to take this answer that we got 12 and plug it back into our original problem. So that would be, instead of w, it would be 12 plus 4 is equal to 16, which is true, so we know we got it right. I'm going to skip to number 4, circle the variable, draw the line, and do the opposite of what it says. It says the variable minus 5. The opposite of subtraction is addition. So we're going to add 5 to both sides. And so we get our solution of z is equal to 13. And when we want to justify that step, what did we do? We did the addition property of equality. And lastly, to solve and see if we got it right, we take our answer of 13, plug it back into the original problem. And so we have z, which is 13, minus 5 is equal to 8, which is true, so we got it right. On number 7, I'm going to circle my variable, draw my line, and I'm going to do the opposite of what it says. Right now, b is being multiplied by 4, so the opposite is to divide. I always suggest that you write division as a fraction because it's going to help you a lot. Fractions are so much easier than writing the division sign. So we get an answer of b is equal to negative 13. And our justify each step, what did we do? We used the division property of equality. Lastly, we're going to take our answer and plug it back into the problem. So our problem is 4 multiplied by negative 13 should equal negative 52, and it does indeed. Okay, let's go ahead and look at number 8. Number 8, we're going to circle our variable, draw the line. Right now the variable is being divided by 11. The opposite of division is multiplication. So I'm going to multiply both sides by 11, and I end up getting 33 is equal to q. And so that's my solution. And what did we do? We did the multiplication property of equality. Lastly, to check our solution, we need to take our answer of 33, plug it into the original problem. So that is 3 is equal to 33 divided by 11, which is true. Okay, I'll go ahead and do number 9 for you as the last one that I'm going to do with you on this set. Circle the variable, draw the line. The opposite of a division is multiplication. So on this one, we're going to multiply by negative 2 on both sides. And I'm going to let you go ahead and finish that number 9. Also finish the other ones that we didn't do, number 2, 3, 5, and 6. Turn the video back on when you're finished and check your answers. Okay, there the answers are finished. Please check your answers. If you made any mistakes, see if you can find them. All right, let's take a look at number 10. A coupon subtracts $17.95 from the price P of a pair of headphones. You pay $71.80 for the headphones after using the coupon. Write and solve an equation to find the original price of the headphones. Okay, let's take that and just break it down a little bit. A coupon subtracts. So I'm going to stop right there, and I see that the word subtracts is there. So what I'm going to do is I'm going to write subtracting $17.95 off of something. It says from the price P. So P minus $17.95 for a pair of headphones will equal what we paid for it, which is $71.80. Okay, so there we have the equation. Now we want to find the original price of the headphones. And in order to do that, we just need to solve for the letter P. You solve the problem on your own and then turn the video back on when you're done. Okay, there I have my answer. You'll notice that I gave my answer in a complete sentence. Anytime you are having you are given a word problem, I would like you to answer in a complete sentence, please. Okay, last problem. After a party, you have 2/5 of the brownies that you made left over. There are 16 brownies left. How many brownies did you make for the party? So let's go back to that. After the party, you have 2/5 of. The word of, remember, means multiplication. So 2/5 of multiplied of the brownies that you made are left over. So if we think about that, then we have 2/5 of some amount, I'm going to put B for brownies, are left over, and we're told that it's equal to 16, so it's equal to 16. Okay, so now we need to solve this. I'm going to go ahead and solve this one for you because some people have trouble with fractions, so I wanted to remind you how to solve this. So we have our letter B here. We want to solve for B. The opposite of multiplying by a fraction, you can divide by this fraction, but it's a whole lot easier to multiply by the reciprocal. And so the reason why you do that is because 2 divided by 2 is equal to 1, so these kind of cancel out. 5 divided by 5 is also equal to 1, so they kind of cancel out. So if we multiply by 5 over 2 on the left side, we also have to multiply by 5 over 2 on the right. And so now we can just go ahead and solve this. My suggestion is, instead of multiplying 16 multiplied by 5 straight across and then 2 multiplied by 1 and then simplifying, it's a whole lot easier if you can simplify first. So in this case, we can simplify 16 divided by 2, get a 1 on the bottom here. 16 divided by 2 is 8, so we have that, and now we can multiply just 8 times 5 together, which gives us 40, and on the bottom we multiply 1 times 1 together, and we get 1. So the answer is, how many brownies did you bake for the party? You made 40 brownies. All right, thanks for watching.